Welcome to this testing demonstration of the liquid level sensor project. So starting off, we have the power supply unit over here providing power to the circuit, and adjacent to it, here the power profiler kit utilized for gauging the current within the circuit. So moving forward, over here is the water level sensor, and as you can observe, the water level is currently above the sensor. So at present the microcontroller is in sleep mode. So we will wait for its awakening so that we can proceed further. Now since the water level is above the sensor level, you can observe a flash coming out of the sensor. So this indicates that the sensor has been triggered, so no beeps are generated, and the microcontroller returns to the low power mode again for 5 minutes. So now let's wait for the next microcontroller wake up and sensor reading. In the meantime, let me change the bottle orientation so that the water level becomes lower than the sensor level, so that we can observe a different behavior. So let's make the adjustment, and we will once again wait for the microcontroller to wake up from its low power mode. Also over here you can analyze the current consumption, which is fairly low, and it's around 11 microamps on average while in the low power mode. So now, as you can see, since 5 minutes have elapsed, the microcontroller is active now, emerging from its low power mode, and this time you can notice a beeping sound from the buzzer since the water level is below the sensor level. So this buzzer beep will repeat for 7 times within 1 minute, and the duration is kept at 10 seconds between each beep. So now you can see the 7 beeps are completed and the microcontroller reverts to low power mode for 5 minutes again. So now again, let me straighten the water bottle so that the water level back to its original position. So instead of 5 minute wait, I'm going to cut off power to the circuit for an easier assessment. So now you can see the power off state. Let me turn it on again. You can notice a flash from the sensor since the water level is above the sensor this time. So the microcontroller re-entered its low power mode and continuing this cyclic pattern. So this setup will repeat for every 5 minutes. Now coming to the analytics sections, let's verify everything we have just saw earlier. As you can see, these narrow spikes represent the 7 beeps. So now let me first verify the interval between two consecutive beeps, which is 10 seconds. Next, let's verify the total interval for all 7 beeps, which is 1 minute. And you can confirm from here. Now let me show you the sleep interval between the microcontroller to wake up events. Let me drag the marker point to the first wake up. And over here, this is the microcontroller first wake up point that we saw in the first section of the demo when the water level was above the sensor. And so the microcontroller wake up here takes the sensor reading and goes into low power mode again since the level is above the sensor, and goes into low power mode again since the level was above the sensor. Over here you can see the total interval of 5 minutes between the two consecutive wake up events. So this is the second point where I placed the bottle horizontally and thus the level was detected lower than the sensor. At this point, the microcontroller takes the sensor reading and here is the first beep. Let's confirm the beep duration as well, which is lasting for 100 milliseconds. Let me confirm the other interval as well. And you can see it is 10 seconds for all 7 beeps. The interval between the starting points of the first beep and the last beep is 1 minute, which you can also confirm here. Lastly, this is the last point where I turned off the supply to cut off power to the circuit and then turn it back on. The water level was detected again, and so the microcontroller reverted to the low power mode again, and you can confirm it from here as well. Thank you for watching this demonstration. If you have any question, please let us know.